The best way to start learning how to use the test strip is to start with a product you know as a non-threat item. So let's start with water. Question one generally is people asking how much liquid are you supposed to put onto the test swab. This doesn't really matter. I would recommend that it's not dripping. So it's just been nicely wetted, but it's not dripping. The next question people often ask is, are you supposed to dab, rub, or just wipe the test swab down the test strip? It really doesn't matter. This will come down to personal preference as you get used to using the device. If we look at test one, if I start rubbing water, which we know is a non-threat item, you can see that basically some of the chemical reagent in the paper has been wiped away and it ends up in the swab tip. This is not a positive reaction, it's a completely normal reaction. It just means that some of the powdered reagent in the test strip has come off onto the test swab. This is completely normal, it is not a positive indication. If we continue down, we're basically seeing that there's no colour changes with our non-threat item, water. Using this as a baseline, we know what water does, which is no chemical reaction, there's no colour changes. From here we'll move on to threat items, which will give us drastic colour changes. Threat item we'll look at is nitric acid. Now, nitric acid is a precursor for many clandestine explosives, even military-grade explosives. Nitric acid is quite readily available, and we'll now look at what this does on the test strip. Firstly, I'm dipping the swab. Again, it's been nicely wetted, it's not dripping completely. Now basically what we are looking for here is some colour reaction with this threat item in the swab tip. Test 1 is a pH test. It tests for acidity and basicity. Test 1 should give us a positive indication if an acid is present or an alkaline basic material is present. If I place the swab onto test 1, we'll be looking to see if there's any colour change now. As you can see, there's been a massive instant colour change. That is an indication of a threat item. That red to purple coloration means there is an acid present in that liquid that we sampled. If I continued bringing the test swab down the device, you can see that it may actually react with multiple test zones on the test strip. You can see there's been a drastic colour change there. That is an indication of a threat item present. Threat item we'll look at is sodium hydroxide. Sodium hydroxide again can be used in the manufacture of clandestine explosives. Sodium hydroxide is at the other end of the pH scale to acids. Acids being acidic, sodium hydroxide basic. The type of colour indication that we're going to see from sodium hydroxide is very indicative of some organic alkaline precursors to explosive manufacture as well. So sampling the liquid sodium hydroxide, enough to wet the actual swab tip. It's not dripping, it's just pre-wetted. Okay. Now I'm going to touch the swab tip onto the test strip. Test zone 1, which is a test for pH, should change colour here. So you can see that the second I put the alkaline liquid, which is the sodium hydroxide, onto the pH test, we get an indication that there is a threat item present. That type of colour indication, as I said before, is very indicative of other alkaline organic liquids that can be used for explosive manufacture. I could run the swab tip down the rest of the test strip, but there's no real colour changes here. Any single colour change on this test strip is enough for you to be alarmed that there is a threat item present. Move on to test 2, which tests for threat organic volatile compounds. We'll just quickly use a comparison of water again to just remind ourselves of what a non-threat item looks like. So dipping into water, test 2 now, I'm rubbing, and there's basically no colour change. In fact, the swab just wipes the reagent off the paper. Okay, I could continue wiping it down, but we've seen it before. water is not a threat item, there's no colour changes. If I move straight now to a threat item, which is a very high concentration alcohol, dipping the swab into the alcohol. Test 1, absolutely no colour change. That's what we expect. Test 2, we can instantly see a drastic pink iridescent formation of colour. We could continue moving down the rest of the test strip, but we've already got a colour change. Still on test zone number 2, we're going to look at now another threat organic volatile compound, fuels. We'll do a direct comparison again with water. So just reminding ourselves, water, nothing with test zone 1, and with test zone 2, again, no colour reaction. Moving directly now to the threat item, the petrol fuel, this is a much more subtle change. And with experience, you should be able to see the colour difference. I've wetted the swab tip in the petrol fuel. Test zone 1, absolutely no colour reaction, as we would expect. Test zone 2, if we start rubbing, we can see an instant colour formation. If I compare that now to the first test strip with water, the water on the left, no colour change. Test strip on the right, the fuel, instant pink formation. Continuing with test 2, which is the detection of volatile organic compounds, volatile solvents. Moving on to just a basic industrial solvent, dimethyl sulfoxide. First of all, we'll use the water as a comparison. So dipping my swab into water, again rubbing the test zone 1, no reaction. Test zone 2, basically the swab just wipes the chemical reagent from the paper. There's no reaction. We could continue wiping down the rest of the test strip, and again there's no colour reaction. If we move straight to looking at the industrial solvent, however, dipping into the industrial solvent, swab tip is wetted. Test zone 1 does nothing. Test zone 2, however, you get an instant colour reaction. If we just compare the water test strip to the industrial solvent test strip, we can see the difference. Water is on the left, industrial solvent on the right. We'll now move on to test 3. Test 3 is actually made up of 3 separate parts, which I'm pointing to with the swab tip here. All 3 need to be mixed together in order for the reaction to occur. Test 3 detects organic compounds or compounds containing nitrogen species. We're going to use nitric acid as the chemical that we will look at here, because nitric acid contains nitrogen and it will actually set off test zone 3. Nitric acid would also set off test zone number 1 because it's an acid species, and test zone 1 looks for acids and bases. We'll first of all start with a comparison with water. Remember, if you're ever in doubt, start with something you know will not give you a reaction. So we'll start with water. Nothing with test zone 1, nothing with test zone 2, nothing with test zone 3, 4 or 5. Water gives you no colour reaction. We'll now move to the actual reaction with a nitrogen-containing species, nitric acid. I won't put the swab tip on test zone 1 or 2 because it's going to react heavily with test zone 1 and colour the rest of the test strip. I'm going to go straight to test zone 3. This is the test we're now looking at to see what type of colour reactions we get with test zone 3. If we wipe the swab down, test zone 3, mixing all 3 parts together, you can see the type of colour indications you'd get at test zone 3. This is a positive test for nitrogen-containing organic species. I'm going to move to test zone 4. Test zone 4 checks for volatile compounds. Test zone 4 should give us indications of blue and green iridescent colours. They are very rapid forming, so you need to look quite closely. I'm going to spot directly onto test 4 and not worry about tests 1, 2 and 3. There should be no reactions in test zone 1, 2 and 3, so we're going to go directly to test zone 4. Again, we'll use the comparison of water first. So dipping the swab tip into water, wiping it on test zone 4, and you can see there's absolutely no colour change. If I now get a swab and place it into a volatile compound, going directly to test zone 4, putting it on, you can see the instant colour formations. I'll get another test strip and we'll do another one. Remember, these are very rapid colour changes, so you need to watch closely. The test we'll look at is test zone 5 at the bottom of the test strip. Test zone 5 detects peroxides. For this particular example, we're going to use hydrogen peroxide, a 30% solution. But to start with, we'll look at the comparison with water. So if we dip the swab tip into the water, rubbing down the test strip, we notice that there's no colour changes. And specifically in test zone 5, the swab tip actually wipes the chemical reagent away, leaving a white background. That is no colour reaction. Moving to the actual hydrogen peroxide, dipping the swab tip into the hydrogen peroxide solution, getting a good sample. We now wipe the test strip with the swab tip, test zone 1, 2, 3, 4, no colour changes, and 5. In test zone 5 we can see the instant formation of a dark brown black coloration. In fact, it's gone into the swab tip as well. We're going to look at some typical examples of liquids that might be tested. Mouthwash. Dipping the swab is wetted, rubbing it down the test strip, no colour changes. Coca-Cola, a soft drink. Dipping the swab into some Coca-Cola, get some off the can lid, wiping it down the test strip. No colour changes. And finally, toothpaste. Taking some of the toothpaste out of the actual container, some toothpaste on the swab tip, rubbing it down the test strip. No colour changes.